Hello everyone, welcome back to my channel. Today we are going to just do an example on counting principle, which is something that you learn in grade 12 probability if you are in South Africa. So the example that we're looking at here, they've given us the word technology. Now what I want us to notice when we look at this word straight away is that there are some repeated letters here. We actually have two O's. So that is going to influence the question and how we approach it. Okay, so for the first question, they're saying how many letter arrangements can be made using the letters of this word. Now, what you need to remember is that you need to check how many letters there actually are in the word. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters all together. So we are going to use 10 factorial to show how many letter arrangements we can make. Now, if you're struggling with that concept, you can always draw lines. So you can do one, oh, sorry, that's the wrong thing. Let me go back. You can draw your lines. You can do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now each line represents a letter of this word. Now, if you're making 10 letter words or letter arrangements, right? They're calling them letter arrangements because it doesn't need to be an actual word that makes sense. It's just we're using these 10 letters and we are scrambling them up to make new letter arrangements, okay? So what you need to think is that for the first letter of this 10 letter word that we're going to make, there are 10 letters that we can choose from, right? Because we can use any one of the 10 letters of the word technology. But say we put a T in the first letter there, in the first slot. Now we are not allowed to use that T again. So now we actually only have 9 letters that we can choose from for the next slot. Now we've used 2. Say we put a T and a Y in the first 2 slots. So there we have TY. Now there are only 8 letters left to choose from for the next letter. And so on. Next up, we're going to have 7 options, then 6, then 5, then 4, then 3, then 2, and finally only 1. So that is where the 10 factorial comes from. But guys, the fact that we now have 2 O's is actually going to limit our options that we have. Because whenever you are swapping these 2 O's around, you're going to get the same word. So if I have this O and my second O, right, in the word technology, what's going to happen if I swap these 2 O's around? I'm going to have the exact same word. So because of that, because we have 2 O's, whenever we swap those 2 O's around, we're actually going to end up with the same word. So we have to halve all of these options that we're getting. We need to divide that by 2 to cancel out all of those repeated options when we are swapping those 2 O's around. Now guys, we are actually dividing by 2 factorial, but hopefully you know that 2 factorial is the same as 2, right? Because 2 factorial is just 2 times 1, which is the same as just 2. So you can just write 2 if you want, or you can write 2 factorial. Okay, that is the first example. We just need to calculate what this value is actually. Let me quickly do that on the calculator. So 10 factorial divided by 2 or divided by 2 factorial. And we are getting an answer of 1,814,400 for the first one. That is the number of letter arrangements that you can make using the 10 letters of the word technology. Okay, next up we're going to look at the second question. How many letter arrangements can be made using this word? We're still looking at the word technology. If the letter arrangements have to start and end with the same letter. Now guys, we only have one pair of letters here that are repeated, and those are O's. So that means that in order for this to be true, if we draw our 10 lines again representing the 10 letters, 7, 8, 9, 10. We are going to have an O as the first letter and as the last letter. So how many options do we actually have for the first and last letters? we only actually have one option for those two. Now you might think that, but ma'am, there are two O's, so surely there are two options for the first O and one option for the second O. But if we just think of the fact that these O's are identical again, if you were to swap the two O's around, you would get the exact same word. So that is why we say that we only have one option for the first O and one option for the last O, because the two O's are exactly the same. If you want to think of it differently, you can just think of the first and the last letters being fixed. So it's set in stone that that needs to be an O and that needs to be an O. So we can actually kind of ignore the first and the last letters in our calculations. Okay, because those are fixed. They have to be O's. Now we need to ask ourselves, now we've used the two O's already. So how many letters are now left? 1, 2, 3, 4, 5, 6, 7, 8 letters. So in these gaps, for the next letter, there are only 8 options. Then 7 for the next option, because the first letter is already there. So we only have 7 letters to choose from. Then 6, then 5, then 4, then 3, then 2, and then 1. Now guys, within the letters that we have now put here in between the two O's, are there any repeated letters? No, right? The repeated letters are the first and last letters here. So now we're not going to have to divide by anything. There are no repeated letters here. So the answer for this question is simply going to be 8 factorial, which is equal to, let me just calculate that quickly. 8 factorial on the calculator is equal to 40,320 words. That means that there are 40,320 words here using the words, or the letters rather, from the word technology that start and end with an O. Okay, for the last example, number 3, they are now saying, what is the probability of a letter arrangement made up of the letters of the word technology, starting and ending with the same letter? Now guys, as soon as they're asking about probability, we're going to have to set up a fraction. So what are they asking for here? What's the probability that the word that we are creating will start and end with the same letter? Now up here in number 2, we calculated how many words there are that we can make using the letters of the word technology that will start and end with the same letter. So this is going to go at the top of our fraction, right? 8 factorial, or this value. So that's going to go at the top. But then at the bottom of our fraction, remember when you're calculating probability, you always take the total number of things, the total number of possible outcomes. So in this case, the total number of letter arrangements that you can make using the letters of this word. So this value up here, our answer to number 1, that is going to go in the denominator of our fraction. So the probability is going to be 8 factorial over 10 factorial over 2. Or if you want, since we've already calculated these values, you can take 40,320 and you can put that over the answer to the first question, which was 1,814,400. And when we calculate that actual value, I'm just going to type it into the calculator quickly. You just would type that in and get an answer. The answer is 1 over 45. So that means, guys, that when you are making up letter arrangements using the letters of the word technology, 1 out of every 45 words will start and end with the same letter. I hope that that was useful. Please comment down below if you would like me to do more counting principle questions and what other topics you would like me to cover as well. And please subscribe, like if you haven't already. I would really appreciate that. Thanks so much, guys. Have a lovely day.